The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are 3 different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@yvcc.edu and I will respond as soon as I can. So today we're going to continue reviewing for the final exam. The focus today will be on Chapter 8. So let's go ahead and get started. And the first section in Chapter 8 that we covered was Section 8.2, which is functions. As we go along, if you have any questions, if I'm going too fast, if for whatever reason you need to stop me and comment, please do. Otherwise, I will continue. So basically a function, let me read you the definition, if I can find it here. It says a function is a set of ordered pairs in which to each first component there corresponds exactly one second component. The set of first components is called the domain of the function, and the set of the second components is called the range of the function. And we talked about kind of like a person and a birthday. Several people can have the same birthday. Several inputs can go to the same output. But for a function, you can't have one input going to more than one output. And we talked about function notation. And let's look at some examples. Let's say that we have the function f of x equals 3x minus 5. And we are to find f of 3 and f of -1. So f of 3, the input or the domain is 3. We're going to put that in the place of x in the function. So that would give us 3 times 3 minus 9, which is, or minus 5, excuse me, which is 9 minus 5 or 4. So f of 3 equals 4. This corresponds to the ordered pair 3, 4. This is function notation. This is ordered pair notation. F of -1 would be 3 times -1 minus 5, which is -3 minus 5 or -8. So f of -1 equals -8. This corresponds to the ordered pair -1, -8. Any questions about that? All right. Let's talk about the domain of a function. Let's say we have the function f of x equals 1 over x plus 4. And we want to know the domain. That is, we want to know what x values can be put into the function so that it produces a real y value. Well, the main thing we need to avoid here, recall that dividing by 0 is undefined. If we take the denominator, which is x plus 4, and we say, when would that equal 0? Well, if we solve it, we get when x is -4. So when x is -4, we don't get a real output. So the domain is everything but -4. Now, to say that in interval notation, we would want everything from -infinity up to but not including -4, in union with everything after -4 on up to +infinity. So basically, this is all real numbers, except we are excluding -4. Any questions there? All right, let's take a look at a graph of a function. For me to do that, I'm going to switch screens, so give me a minute here. And let's see here. Oh, we've got it in green this morning. I'm going to switch over to black because I think that's easier to see. And we'll put a scale on there. All right, let's say we've got the function f of x equals 2/3 x minus 2. This function is already in slope-intercept form, so the slope would be 2/3 and the y-intercept would be -2. So over on the graph, I would plot the point 0, -2, and then using the slope of up 2 over 3, I will plot some additional points, and then I'll come back and draw the line. Let's see here. So there is the graph of f of x equals 2/3 x minus 2. Any questions there? All right. I don't know if this is actually faster than doing a new graph or not, but suppose we got f of x equals -x. This is also in slope-intercept form. The slope would be -1, that's the coefficient of x, and the y-intercept is 0, because f of x equals -x is like y equals -1x plus 0. So using this information, the y-intercept is at the origin, we'd go down 1 and over 1 using the slope. And let's see here. And so there is the graph of f of x equals -x. Any questions about that? All right. We're going to look at one more example here. How about f of x equals 2, which again is kind of like, well, it's just like y equals 2. That would be the equation of a horizontal line passing through y equals 2. Let's see here. All right, we're going to go back to the other screen now. So can everybody see my whiteboard screen now? Just somebody let me know I've switched it.
Yeah.
Great, thank you, Anna. Okay, let's say we have, it says write an equation for a linear function whose graph has the given characteristics. It has a slope of 5 and a y-intercept at 0, -3. So basically we could say that m is 5 and b is -3. So y equals mx plus b would become y equals 5x minus 3, and writing it as a function, f of x equals 5x minus 3. Any questions there? All right. Let's say we have we want to write a linear equation with the following characteristics. The equation passes through the point 1, 7 and -2, 1. Again, I want to write my answer in y equals mx plus b form and then using function notation. So I need to find the slope and the y-intercept. We're using the slope formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. I'm going to call this point 1 and this point 2. So y sub 2 would be the y value of point 2, which is 1. Y sub 1 would be the y value of point 1, which is 7. X sub 2 would be the x value of point 2, which is -2. And x sub 1 would be the x value of point 1, which is 1. 1 minus 7 is -6. -2 minus 1 is -3. -6 over -3 is 2. So the slope equals 2. So now I'm going to take y equals mx plus b, and I'm going to put 2 in there. I'm going to take one of these ordered pairs and put that in for x and that in for y. So 7 equals 2 times 1 plus b. 7 equals 2 plus b. Subtract 2, 5 equals b. So I've got the slope and the y-intercept. Y equals 2x plus 5, or f of x equals 2x plus 5. Any questions there? Okay. Let's see. Let's say we've got a graph that passes through the point 3, 0, and it's parallel to the graph of g of x equals negative 2/3 x minus 4. Parallel lines have the same slope. The slope of g of x is negative 2/3. So the slope of the line that we're looking for is also negative 2/3. So using y equals mx plus b, m, the slope would be negative 2/3. Taking the ordered pair we have and putting 3 in for x and 0 in for y, we get the following, which says this, add 2 to both sides and 2 equals b. So y equals negative 2/3 x plus 2, f of x equals negative 2/3 x plus 2. So here's the equation of the line that's parallel to this line. They have the same slope, and it passes through the point 3, 0. And let's see. How about a graph or the equation of a line that passes through the point 1, 2, and it's perpendicular to the graph of g of x equals, let's see here, 9x plus 5. Okay, so the slope of g of x is 9, but the slope of the line that's perpendicular would be the negative or opposite reciprocal. So the slope of the line we're looking for is negative 1/9. So using y equals mx plus b, m would be negative 1/9. So negative 1/9 x plus b. We'll take this ordered pair and put 1 in for x and 2 in for y. So we get 2 equals negative 1/9 plus b. We'll add 1/9 to both sides. So b equals 2 1/9, or what, 19/9. So I've got this slope and this y-intercept. Y equals negative 1/9 x plus 19/9. F of x equals negative 1/9 x plus 19/9. And finally, we want the equation of a horizontal line passing through the point negative 8, 12. We'll recall the equation of a vertical line is x equals some constant. The equation of a horizontal line is y equals some constant or some number, okay? Well, the only y value we have is 12, so y has to equal 12, or f of x equals 12. All right, and with that, we're going to press onward to section 8.3. And here, we're going to look at some graphs. So we'll get rid of this and go back over to the graphing screen. And let's see here. Okay. Here, 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 and here. Let's say we've got this graph. And the graph looks like this. Oops, I was supposed to cross that point and I didn't quite cross it. Okay, so I want to emphasize some specific points because my graph is rather poor. And let's say that this is the graph of f of x, all right? And we want to find f of 1. So looking at the graph, where is x equal to 1? Well, x equals 1 would be right there. What is the corresponding y value? 4. So for this function, f of x, f of 1 is 4. How about f of 4? Well, when x is 4, y is -2. How about for what values of x is f of x equal to 0? Well, let's see. That would be when x is what? -7, 4, 1, 3, and I'm going to fudge this a little bit. I'm going to change my line to where it's over there, just so that it's easier to tell where it crosses. Okay. So we'll make it so that it crosses right here, which is what? It's 7. So f of x is 0 when x is either -7 or, oops, -4 or -1 or 3 or +7. Sorry, I forgot my signs there. Okay with that? What would the domain of this thing be? Well, since this travels up forever and this travels down forever, it would be all real numbers. What about the range? Well, since as this travels over and up and down and over, the range is going to be all real numbers as well. Okay, let's take another look at an example, or let's see here. And let's say we have this, and then let's make our graph red. And let's say it looks like this, and then like that. Okay, so what's the domain? Well, this arrow is going to the right forever. This arrow is going to the left as it goes down forever. So again, the domain would be all real numbers. What about the range? Well, the range, this is going down forever, but the highest point here is this, which is, let's see, that's what, 7? So the range would be from -infinity up to and including 7. Any questions on that? Okay. We're going to go on to the next section, which is, let's see here, 8.4, solving compound inequalities. And let's see, recall that intersection, the intersection of two sets is the part they have in common. We use an upside down U to imply intersection, or we use the word and to imply intersection, depending on what context we're in. And then we have the word union. The symbol for union is a U, and the word that implies that is the word or. So intersection, upside down U, the word and, union, a U, or the word or. Let's say we've got the following. it says 2x minus 1 is greater than 3, and x plus 8 is less than or equal to 11. It says solve each compound inequality, if possible, graph the solution set if one exists, and write it using interval notation. So the first thing I need to do is solve each inequality. So for the one on the left, I'll start out by adding a 1, dividing by 2, so I get x is greater than 2. Solving the inequality on the right, subtract 8, x is less than or equal to 3, which I'm going to bring down here, and I'm going to bring this and down. So basically here is what I'm going to deal with. Now, x greater than 2, the graph of that would be what? Parentheses, arrow going to the right. X less than or equal to 3, the graph of that would be a bracket on 3 with an arrow going to the left. But we want the intersection. So we want where they overlap, which would be right in there. So the graph of the part that overlaps, we would have what? Parentheses at 2 and a bracket at 3 with a solid line in between. That's where they overlap. And writing the answer in interval notation, it would look like that. So there's the graph, there's the interval notation. Let's see here. Let's say we've got an example like this. X minus 3 less than negative 4, or negative x plus 2 less than 0. Again, I'm going to solve each inequality separately. The one on the left, I'm going to add 3 to both sides. X less than negative 1. The one on the right, I'll subtract 2. Negative x less than negative 2. But now, do you recall when you multiply or divide both sides of an inequality by a negative number? We talked about this a couple of days ago. You change the direction of the inequality symbol. So I've got x less than negative 1 or x greater than 2. All right, well, let's take a look at x less than negative 1. Let's see here. That would be parentheses at negative 1 with an arrow going to the left. X greater than 2, that would be, let's see here, parentheses on the opening or on 2 and the arrow going to the right. But union is all of it, everything, not where it overlaps, but everything. So our union graph is going to look like this. Let's see, 1, 2, negative 1. We're going to have this piece, and we're going to have that piece. So 2 separate pieces, which means that when we write it in interval notation, we're going to have from negative infinity up to negative 1, but not including negative 1, in union with after 2 on up to infinity. You might recall back in this chapter, I talked about the idea of Hawaii, where Hawaii is a state. It's a union of a bunch of islands, but geographically, those islands are separated. But when we talk about the state of Hawaii, we include all of them. So here's like I've got 2 separate islands, but their union includes all of it. Okay. Let's take a look at a double inequality. Let's say we've got negative 5.3 less than or equal to x minus 2.3 less than or equal to negative 1.3. So I've got 3 parts. Part in the middle where I want x to be by itself and parts on both ends. We can get rid of the decimals or leave them. I'm going to get rid of them. So what I would do is I would multiply each piece of this by 10. So on the left, I'm going to get negative 53 less than or equal to 10x minus 23 less than or equal to negative 13. Okay, and I don't have to get rid of the decimals, I just choose to. But now I want to get x by itself in the middle. So I'll add 23 to both sides. So I get negative 30 less than or equal to 10x less than or equal to 10. And now I'm going to come back and divide by 10. I know that seems kind of silly. I multiplied by 10 and now I'm dividing. But again, we could have done it without getting rid of the decimals. Negative 3 less than or equal to x less than or equal to 1. And if we were going to graph that, which we will, let's see what that would look like. We've got 0 and 1, negative 3, negative 2, negative 1. We're going to include negative 3 and include 1 and have a solid line segment in between. And writing it in interval notation, it would look like that. Okay. Let's see. I think with that, I'm going to move on to the next section, unless there's any questions. Nope. Okay. We're going to go on to section 8.5, solving absolute value equations. All right. So let's say we've got something like the absolute value of x plus 3 equals 12. So we have an absolute value that's isolated equal to a number. Okay, so that means we're going to have two possibilities. What's inside the absolute value bars must equal 12, or what's inside could equal the opposite of 12 or negative 12. Because if what's inside is equal to negative 12 and we take the absolute value, we would get a positive 12. So now solving these two equations, I get x is 9 and x is negative 15. Let's check our work. If x is 9, we'd have 9 plus 3, absolute value equals 12, absolute value of 12, 12 equals 12. So this one checks. Let's check this one. Absolute value of negative 15 plus 3 equals 12. Absolute value of negative 12 equals 12. But the absolute value of negative 12 is 12. 12 equals 12, and that one checks. So again, what's inside has to either equal 12 or negative 12, so that when you take its absolute value, positive 12 comes out. Any questions there? All right. Let's say we've got a situation like this. Let's see, let's back here. We've got the absolute value of 6x minus 3 plus 7 equals 28. The first thing we want to do is isolate that absolute value. So I'm going to subtract 7 from both sides, which gives me this. So now what's inside either has to equal what's on the right side, or what's inside has to equal the opposite of what's on the right side. That is the right side of the equal sign. Solving the first, the left equation, adding 3, we get 6x is 24, divide by 6, x is 4. Solving the right side equation, adding 3, we get 6x equals what? Negative 18. Divide by 6, x equals negative 3. Let's check our answers. If x is 4, we would get the absolute value of 6 times 4 minus 3, plus 7 equals 28, which would be the absolute value of 24 minus 3 plus 7 equals 28. The absolute value of 21 plus 7 equals 28. The absolute value of 21 is 21. 21 plus 7 equals 28. Let's take x is negative 3, and let's check that. We'd have the absolute value of 6 times negative 3 minus 3 plus 7 equals 28. The absolute value of negative 18 minus 3 plus 7 equals 28. The absolute value of negative 21 plus 7 equals 28. But the absolute value of negative 21 is 21. 21 plus 7 equals 28. 28 equals 28. So this one checks as well. I feel like I'm traveling at the speed of light here, but I'm trying to get through all these sections, and you can always go back to the YouTube channel and take it as slowly as you want. Okay, now let's say we have an absolute value equal to 0. So we've isolated the absolute value, but we would get two equations. What's inside equals what's outside, or what's inside equals the opposite of what's outside. Well, 0 and the opposite of 0 are both 0. So basically, when you've got a single absolute value term equal to 0, you're only going to have one equation. And solving that, we get x equals -2. And if we plug that in, we get what? The absolute value of 0, 0 equals 0. So it checks. And another case, let's say we have an absolute value equal to a negative number. Well, let's see. That means either 2x plus 5 equals -10, or 2x plus 5 equals the opposite of -10. Here, we would subtract 5 and we get 2x equals -15, or x equals -15 halves. Over here, we'd get 2x plus 5 equals the opposite of -10 is 10. Subtract 5, 2x equals 5, divide by 2, x equals 5 halves. So we have two potential solutions. However, when we go back to check our work and we plug them in fact, what I'm going to do here, I'm going to erase this so that I have a place to write without having to cram it all in together. Okay. So if we're going to check this one, we would have the absolute value of 2 times -15 halves plus 5 equals -10. Well, this would be what? 2 times -15 halves would be -15. -15 plus 5 would be -10. The absolute value of -10 is 10, so we get 10 equals -10. Well, that doesn't work. So that would be a solution that doesn't work. Yeah, and I think in WebAssign, it kind of goes through and gives you instructions on to find the solutions and then tell whether they're correct or not. And then let's use 5 halves. The absolute value of 2 times 5 halves plus 5 equals -10. We get what? The absolute value of 10 equals -10. 10 equals -10. That doesn't work either. So there's no solution. Now, again, I think in WebAssign, they actually have you identify those solutions and then say that they don't work. All right. Anytime you've got an absolute value set equal to a negative number, you're not going to get solutions that work because absolute value can't be negative. It's always positive or 0. Okay. One more example here. Let's say we've got an equation where you've got one absolute value equal to another absolute value. So here you've got two cases. What's inside of one equals what's inside of the other, or what's inside of one equals the opposite of what's inside of the other. Recall there's 4 cases, but when we look at them, there's only 2 that are unique. Solving the first equation, excuse me, we'll add 2 to both sides. 6x plus 3 equals 9, subtract 3, 6x equals 6, divide by 6, x is 1. Solving the second equation, 4x plus 3 equals, distributing the negative, -9 plus 2x. We'll subtract 2x from both sides. 2x plus 3 equals -9. Subtract 3. 2x equals -12. Divide by 2, x equals -6. So once again, I'm going to check my work, and I'm going to erase my writing here so that I have room to check my work. If x is 1, we get the absolute value of 4 times 1 plus 3 equals the absolute value of 9 minus 2 times 1. This would be what? 4 plus 3, 7, 7. This would be 9 minus 2, 7, 7. So that one works. Okay, x equals negative 6. 4 times negative 6 plus 3, 9 minus 2 times negative 6, negative 24 plus 3, negative 21, 21, and here 9 plus 12, oops, 21, 21, it checks. All right. And that takes us to our final section, which is section 8.9, variation. There are 3 kinds of variation. Direct variation, which generally speaking, let's see what variables they use, looks at y equals kx. Then we have inverse variation, which is y equals k over x. And finally, joint variation, y equals kxw, or something like that. Now, direct variation, as x goes up, y goes up. As x goes, oops, as x goes down, y goes down, okay? Inverse variation, as x goes up, y goes down, or as y goes down, y goes up, x goes down. So direct variation, they go up together or down together. Inverse variation, when one goes up, the other goes down. When one goes down, the other goes up. Joint variation is kind of like direct variation, except you have more than one variable on the right side of the equation. And recall that k is the variation constant. It's always there. Sometimes it's mentioned, sometimes it isn't, but it's always there. And it's always on top on the right side of the equation. Okay. So let's go back and let's talk about direct variation, y equals kx. And let's look at an example of that. This says, an object in free fall travels a distance s that varies directly to the square of the time t. So s varies directly to the square of the time t. So even though our general form is y equals kx, they will introduce different variables. We've got t is time and s is distance. So again, it says, an object in free fall travels a distance s that varies directly to the square of the time t. If an object falls 1,024 feet, so that's s, in 8 seconds, so that's t, how far will it fall in 10 seconds? So we're going to take the given information, and I'm going to go ahead and put the 64 in front of the k, and I'm going to use this to solve for k, for the variation constant. So let's see, on my calculator here, I've got 1,024 divided by 64, which is 16. So now that goes up here. And that's what my general equation for this problem looks like. Now there's a follow-up question. How far will it fall? So that's s in 10 seconds. So t is 10. This would be what? 16 times 100, or 1,600 feet. So I have to figure out what my starting formula looks like based on what kind of variation it is. In this case, direct variation. I'm given some information I plug in to determine k. I put k into the general equation. Then I'm given some follow-up information to find a final answer. All right. Let's take a look at an example of inverse variation. Y equals K over X. Let's see here. The frequency of vibration of air in an organ pipe varies inversely to the length of the pipe. So let's see. We'll say the frequency of vibration is F. So that varies inversely to the length of the pipe. So F is going to be the frequency of vibration, and L is going to be the length of the pipe. Okay? So the frequency varies inversely to the length of the pipe. If a pipe 2 feet long, so that would be the length, vibrates 256 times per second, so that's the frequency of vibration. Now, that will allow us to determine what K is. Let's see, that would be 512 equals K. So then that goes up here, and our equation becomes F equals 512 over L. How many times per second, so that's the frequency, will a 6-foot pipe vibrate? So we get that, putting 6 in. Then if we take 512 divided by 6, we get 85.3 repeating, which is 85 1/3 times per second. All right with that? Apparently so. Okay. And then let's take a look at an example of joint variation. It says the number of gallons of oil that can be stored in a cylindrical tank varies jointly as the height of the tank and the square of the radius of its base. All right, so what have we got? I'm going to let G equal number of gallons that the tank will hold. H is going to be the height of the tank. R is going to be the radius of the base of the tank. Oh, they tell us that the variation constant, so K, is 23.5. And we've got this drawing of this tank. This terrible drawing that I'm making here, of course. This is 20 feet. And this distance is 15 feet. So it says the number of gallons, G, varies jointly. So K is there as the height, H, and the square of the radius. So G equals KHR squared. Okay. Now, G equals, they tell us K is 23.5. The height would be what, 20 feet. Careful, what's the radius? Half of 15. So that'd be 7.5, but the radius is squared, okay? So now let's see. If I take 23.5 times 20 times 7.5 squared, I get 26437.5, and that is what, gallons. So how many gallons will it hold? Okay. Well, there you go. I made it with five minutes to spare. I know it felt like a race, but I wanted to give examples of everything. And as I say, you can go back and look at it slowly on YouTube if you want. Tomorrow, we're going to go on and take a look at Chapter 9 questions. And I will be back this afternoon at 1:15 for my office hour. I'm going to stop the recording.